All right, okay, everyone. This is the first lesson of the new chapter. So we're going to start a chapter on geometry. And some of this section will be a little different, a little more applicable, kind of more real life than some geometry you've seen in the past, but we'll be asking you to sort of think about the previous geometry things you've learned. So here we go. So, where do we see geometry in real life, as they say? Um, what certain geometric shapes are important in construction and building, things like that. We'll kind of relate some of these things to real life skills. So the first one, though, we're going to talk about is sort of geometry in art. There's lots of like string patterns you can do. The center there reminds me of those string patterns you might have done where you can make curved lines by joining a bunch of straight lines from one side to another along a right angle or whatever. But other one I want to get into is like geometry and logos. So I bet a lot of these are pretty obvious. The most obvious, probably the central one here, right? The Apple. This one's not I have a label for this one, but clearly, Nike. Now, when we're looking at these things, what I want you to, if I was asking a question about this, I'd be like, oh, what are some geometric aspects to design, and what are the real life kind of connections, right? And so you can obviously point out here at the Apple that you've got like a circle shape, right? And then the idea like I'm assuming there's people that have talked about this logo, like you're taking a bite out of the apple. Clearly, maybe that means like you're consuming their product or something. Who knows, right? Seems kind of obvious though. But you've got obvious curves here. You might talk about like the mathematical equations of those curves. Maybe straight lines. In all these logos, you can probably you can talk about the geometric aspects of it. This one here you might recognize as a TV studio, right? The NBC studios. Obviously, you've got like triangles, and you've got, if you're trying to construct this thing geometrically, you've got triangles and semicircles. Of course, CDC, you might recognize, hopefully recognize that one. This one's a little older. You know what that one is? Think about that one. That's BlackBerry. It's one of the, I think they're still around too, but not as common. And then down here you've got the old version and the new version of Adidas, or as my brother always said, Adidas. But yeah, lots of geometric patterns you could look at there, of course, right? You've got like a trapezoid kind of shape here, or you could break it up into composite figures like previous math classes where you have a rectangle and a triangle, and so on, right? Triangle there, whatever, right? This is the idea of all of the geometry and design, and possibly like the meaning or why they chose those designs, why they're a nice design, why they're a good design. So continuing on here, I think we've done some of these. We did the Adidas. We didn't do any of those other ones, I don't think, right? But we don't have to spend a ton of time on that. But just thinking about the patterns and designs, you probably recognize a lot of these, Target and Twitter and the Olympics, of course, and Windows and Instagram. Like they're just instantly recognizable because they're effective symbols that we're familiar with. The play button from an old VCR and the YouTube is kind of slick, right? So the Adidas, there's some history about some of these things. Adobe, they used to have this logo, and then they sort of switched to be more generic. So just basically getting you to start to think about and notice the aspects of geometry and design, right? Red Cross, obviously just two rectangles or a plus symbol. Twitter, I've never seen this one. That logo is pretty terrible. They switched to this one, which has a lot of nice geometric shapes in it. It just tends to be pleasing to the human eye, right? Circle with these arcs for Spotify. HSBC with triangles for some reason. Target, obviously, it's like an archery target, which makes sense, and so on, right? So anyways, geometry being prevalent in logo designs is kind of an interesting thing to just sort of talk about and look at. The next one, maybe geometry and fashion. When you might start to notice, someone's shirt or designs in their clothing. You'd be like, oh, look at the geometric figures there, whatever. Kind of neat. That's obviously just for visual aesthetics rather than having a deeper meaning possibly in some of these. In building, geometry and structures or architectural design, sometimes the design is just aesthetic, like just for looks, and sometimes it's for purposes, right? For strength or something like that. These are just some neat structures that were in the 2008 Olympics in Beijing. This one caught my eye because this occurs in nature where you get like bubbles in nature, and then you end up with like geometric shapes, basically like these. Like you think of that as like a 1, 2, 3, 4, 5, 6-sided figure, your regular hexagon. Like you get these geometric shapes that show up in nature for surprising reasons, so just in bubbles forming in a surface. It's just kind of neat. And this one has like an ellipse shape, all sorts of neat geometrical shapes, right? Sometimes in architecture, it's more just to be eye-catching, right? City skylines are just interesting. And people go, I want to go there someday because it just looks cool, right? Instantly recognizable. You likely recognize this as the Sydney Harbour in Australia because of I think that's an opera house, isn't it? Someday I'll go. You might recognize that one. You might even live there. Toronto, of course, CN Tower. You recognize that one? Might need to recognize that one. I believe that's Seattle, the Space Needle, I think it's called. This one, I don't know. Let me know if you recognize that one. I didn't look up what that one is. I bet you someone recognizes it though, because it has this like neat geometric, aspect to the cityscape, right? I wish I had the cityscape with this one in it. If anybody finds it, just put it in maybe one of those discussion posts to share. It'd be kind of neat to see this one if it's tall enough to sort of stand out. But obviously a lot of triangles in that design and kind of some neat architecture. Probably creates some good views out of the office windows in there. What do I have here? All right, so geometry and design. Let's see this one here. I'll find that video. Forgot I was doing that one first here. Geometry and design is the Futures channel here. Geometry design backpack. So I'll just play this quick here. Yes. Let that finish here. See if I can get away with canceling that. Looks like it.
Solving a problem is one of the key elements of design, as well as having a pleasing thing to look at. If you can tie the two of those together, that's pretty much perfect design.
See all the geometric shapes.
Hi, my name is Chris Arajo. We're at Columbia Sportswear, and I'm a backpack designer. Well, backpack always has back straps, a haul loop so you can tote your bag around, zippers for entry into the backpack, the fabric that you make it out of, and then the stitching that attaches all the pieces together. Here you can see it broken down into all of its parts, which is called a pattern. The easiest one to identify is probably that front panel. Then you got your zipper, just sewn into these two side panels, which are located here and here. Over on the back, you got the molded back plate. The trick is to be able to take a bunch of separate parts like these are and create an overall form. Each of these parts, in order to create the end product, has to have individual dimensions. This particular panel starts at 9 1/4, dropping down to 6.5 inches, 1.5 inches to 6 3/4 of an inch. The overall dimension of the bag is what creates the internal volume.
You could think
Volume
about
is simple.
You could think about the geometric shapes, three-dimensional shapes that make up the backpack. If they're calculating the volume, I think maybe he talks about this next.
Full measurement, height by width by depth.
There you go.
The bigger the bags, it seems the better. So more books, more food, or more clothing that you can pack inside the bag. Math and geometry are extremely important to understand. How if you're out by half an inch, what change does that do to your overall design? Because you can't design a great product without it working right. You can design the exterior, make it cool looking and everything, but it also has to function well. If it's too thick, it encroaches too much upon the neck. If it's too thin, it puts too much pressure on the shoulder blade. So having the right measurement for that strap is crucial for comfort. Across all fields of design, you start out with ideation. You can just draw some basic shapes at first. It's whatever pops into your head. It's a very creative process. You can put an arc in there. You never get it right on the first try. You might get a little piece of something that you like. So your ideation is kind of your first creative idea or the first thought of the end product. From there, we usually pick a couple of our favorites, and that gets developed further into more advanced sketches that are more detail-oriented. Those sketches then get translated onto the computer. The dimensions are laid out, everything from zipper placement to logo placement. This drawing is the only thing that really communicates what that design is going to be. We specify what colors. The factory gets that blueprint and then makes a prototype bag. The prototype is the first bag with that particular design. Then after it comes back, we see a physical bag. We review that prototype, make any changes to the drawings. Then it would go through a second prototype or even a third prototype until we end up with a final result, which everybody's happy in the group with. The design process is universal. You're coming up with the creative ideas behind the product. You can design anything from footwear to backpacks to watches. It's all the same process. So if you have a pen and a napkin and have a good idea, you're a designer. You can come up with that. And my job is to create those ideas every day.
So we're going to be looking at a version of like the blueprint design, and blueprints for a three-dimensional object like that are a little bit complex, right? So I'll show you in the next lesson what we look at in comparison to that. So the new stuff here, just to keep going with some neat stuff, surprising geometry. We're looking at wheels. Most people think they need to be like circular in shape, right? So just jot that in there. So it's need to be circular in shape, and just have some neat little surprising kind of geometry videos to do with this. And so this is a square-wheeled tricycle. That's the video I was on earlier here, which is surprising geometry, square-wheeled tricycle. So this is kind of weird. See how smooth the ride is? Not going up and down at all. The trick being, of course, that it's square wheels, but it's on inverted catenary curves, basically. These are different kind of, we talked about sine, cosine, tan. There's hyperbolic cosine curves that make this inverted catenary curve, and a possible use for it that you might not have thought of, right? That you have this center of that square can ride along perfectly level, and yeah, even though it looks like it shouldn't. And I saw recently, I didn't catch that, I couldn't see, oops, let me stop that thing, play again apparently. There we go. Close it out this time. I saw recently a video, I couldn't find it just quick because it's one of those ones that shows up and then disappears and you don't see it again, but someone was sort of floating the idea that that could be a possible explanation for how Egyptians moved large blocks. Maybe they had a pathway that was carved, dug out to be these curved shapes, and then the big blocks literally could just roll much easier along that. probably more likely they just had rollers or logs underneath them and just did it that way. But something you might not have thought of, right? When you see something like that, you see that maybe it would apply to something. Could be another invention coming up, something you hadn't thought of. Surprising geometry continued. These weird little acorn kind of shapes are referred to as solids with constant width, which are kind of neat. So you have these little things, and regardless of how they're oriented, the distance top to bottom is always the same. And so that book would roll around surprisingly, like basically like it's on complete ball bearings or spheres, which it doesn't look like it should, right? It'd be the same as if there was just 3 perfectly circular balls underneath that book. Just surprising geometry that exists, but you might not have ever thought of. This one's not as significant or not as, to me, as interesting, but the triangle wheel bicycle, these ones are designed to ride fairly smooth, maybe not so smooth, but you notice the suspension's working hard here to make it happen, right? So the suspension's designed to go up and down in sync with the triangular wheels. And obviously it's just for eye-catching, it's probably a marketing thing or an advertising thing or something. And then applications in geometry, of course, we kind of alluded to the idea of the shapes for strength. So triangles are a huge one for strength. The dome shape on top here is very good for strength. The shapes here for aerodynamics, and so on, all things you could recognize. So obviously the circles are the tires for smooth rolling normally, unless you have inverted cantenary curves. The curved body shape, which looks nice and it's aerodynamic, rectangles in the spoiler, creating downdraft. You can think about the shape and the purpose of it. Would there be a different shape you could choose instead? And so on. Triangles in the frame structure, as I mentioned, for strength. Triangles in the frame structure in barns, the dome, like all for strength there. This is a video from a Storage Wars, I think it was, and these people had these whatever they were taking out of the storage locker, and it was on a trailer, and they're all standing up, and they had them braced by just having boards across. And immediately, as I'm watching it, I'm thinking, that's not very stable, because the whole thing can tilt. And sure enough, it did, and they probably did it on purpose in the show, right, to create interest. But if they had have made supports triangular across, it would have stayed nice and steady, would have stayed put, right? Because triangles create too much strength in structures. So, and that's something you'll see around lots of places, right? You happen to pop by Paris for lunch or something like that. The Eiffel Tower is pretty recognizable. And what are those repeated shapes? Obviously, you've got the triangles, and you've got dome kind of arches as well, right? So both of those help a lot with strength, of course. And how does it affect the appearance? Well, it's a pretty iconic structure. Again, here, geometric shapes, obviously the strength of the dome in an igloo. Going back to the idea of the design features of things, I shifted that up further in the lesson, I suppose, by the backpack. But obviously, those are all things that you could talk about. Do this, what are the geometric shapes, and so on. The evolution of the design of the rim on the cap. You can tell what decade you're from by the shape of the rim, I suppose, right? And things like this, just like being able to just pick out basics of like primary shape of a cereal box, obviously a rectangular prism, right, or rectangular box. Why is it useful? Well, that you can talk about is you can stack them side by side very easily, things like that. Recognizable as a cereal box, like if you had a cylindrical container on a shelf, it was cereal. People might not even recognize that it's cereal and not even pick it up and look at it if it's some odd, unexpected shape. So that's about it for that. The questions here are along those lines. Talking about the design features of this logo for a honey producer. Sketch a honeycomb yourself. Just Google it if you have trouble, but sketch a honeycomb, and then think about if you tried to sketch a honeycomb with like different base shapes, right? Instead of hexagons, if you tried to do with triangles or or squares or whatever, what advantages or disadvantages would there be? I suspect it would be mostly disadvantages, since bees have sort of naturally ended up choosing the hexagon. If there's videos about this, Google or YouTube, why bees use a hexagon. Kind of a little bit of an interesting watch about that if you're interested in that kind of thing. But yeah, the rest of them should be pretty straightforward. Let me know if you have any questions. As always, let's get you posting in, let's go page here. I'll just show it quick. If you're looking at posting a question, use your post questions, discussion group. Post questions here is a couple of clicks because of how I'm using the system to do this. But you just start a new thread, and in the thread, you'll be able to see questions and see the help that's provided, which is nice because everybody gets to benefit from that question and that help. So let's see the rest of it right now, but you get the idea. Okay. All right. So if you have any questions, post them there, and yeah, good to go for now. Let me go back here. Here we go. Until next time, everybody. See you later. Take care.